Okay, solve the following differential equation. Okay, step one, I suppose we got to factorize out the y there. So we get y into x plus 1, and that's x dy dx. Bring the y over, we get 1 over y dy dx. Bring the x underneath, and you get x plus 1 all over x. Most people were here, okay? Now next part is 1 over y dy ends up to be, what's x divided by x? 1 plus 1 over x. We would have done one exactly like this before, and that's roughly your setup. Next part after that, you got to differentiate both sides. What's the upper limit on this one? Upper limit? Y. Bottom limit? 1, because it says when x equals 1, y equals 1. Integrate both sides. 1 over y dy ln y. Okay. Integrate x. Integrate 1, I mean, sorry. When you integrate 1, you get x. When you integrate 1 over x, okay, and you have that from x to 1. Scroll down another slide. This part here, ln y minus ln 1. What is ln 1 again? Huh? ln 1 is 0. Then we have x plus ln x minus open brackets 1 plus ln 1. Now what do we get here? ln y equals ln x plus x minus 1. Okay, you can do two things here. Can anybody tell me what's e to the power of ln x? X, okay? So there's two ways to do it. The way I might have done it was I would have brought the ln x over to your side, and I would have said ln y minus ln x equals ln y over x equals x minus 1. I would have done the rule with the base e. So that's technically log to the base e y over x equals x minus 1. And what I'd have done there was would have converted the log into y over x equals e to the power of x minus 1. Cross multiply up the x like that. Okay. Some of ye had a different way. Your way was to just do ln. Just change y into e to the power of ln x plus x minus 1. Then what you did was you grouped the powers like that, and then you converted your e ln x back into x that way. Some of you just lumped it all in one go. You said y equals e to the power. You left it here. Yeah, just be aware that there is a smaller breakdown after that if it's on. I'd imagine you get full marks for that as well. Is that right, guys? Is there anything about the logs you need explained, or how I shifted up the e, or do you just have that nailed down at this stage? You good? Okay. Now, next one. This one probably would have had a bit of a better go at it, but some people did alright. Okay. A force of magnitude 2m x5 thrusts a particle of mass m directed away from fixed point O, where x is the distance of the particle from O. The particle starts at rest. Okay. Now, x equals d, and show that the velocity. Excuse me, guys. Okay. Rests. X equals d when phi equals 0. X equals root 3d. Find the v value. Okay, you always have a choice, okay? So you go force equals 2m over x5. Force is ma. ma equals 2m over x5. Technically speaking, a equals 2 over x5. Okay, there's two ways you can write down acceleration. You can write down acceleration as change in velocity over change in time, where velocity is the change in distance over change in time. You can then expand that using the chain rule, where you have the v and the t, and you put the x on the bottom, and then you find out that a is actually phi times the v dx. We're going to go for phi to v dx, okay? So now we're just here. We have phi to v dx equals 2 over x5. I'm just going to write down some limits while I'm here. I'm going to say phi equals phi when x equals, is a root 3d? Root 3d, and phi equals 0 when x equals d. Alright, oh dear. Alright, x equals root 3d, x equals d. Okay, the d is outside the root 3. Now, okay, what we're going to do next is this. We're going to integrate, or sorry, first set up the equation. Okay, phi to v ends up to be 2 x minus 5 dx, and put in some limits here. 0 d and phi and root 3 d. Okay, integrate. Phi squared over 2 from phi to 0 ends up to be 2 times. Now what happens when you integrate x minus 5? What does that turn into? 1 power up. Huh? It turns into x minus 4. And then I have to divide by the new power, which is over minus 4. So I have 2 divided by minus 4, x minus 4. And that seems like a lot of fun. Root 3d and d. That's a real pain is what that is. Phi squared over 2 equals, that's minus a half. So I'll just write over here, minus a half all over x, minus a half x4. So let's find out what we're going to have here. We're going to have minus a half. Instead of x4, I'm going to have root 3 d to the power of 4. And then I'm going to have minus a minus. And then I'm going to have d to the power of 4. That's a plus a half d4. Now, what's root 3 to the power of 4? It's definitely d4. But I'm looking at the root 3. And I'm looking at the power of 4. So that's going to be 9. 2 times 9. 2 times 9 is 18. It's going to be 18, okay? So 1 over 18 d4 equals phi squared over 2. Okay. Now, 1/18 plus a half. Anybody? An 18 plus a half? Sorry? Huh? Is it 10 over 18, is it? Okay, I'm losing it. Shh. Oh wait, sorry. My fault. Minus an 18th plus a half. I knew it went wrong somewhere. So it's 8 over 18 d4. Bring the 2 up. It comes to be 16 over 18, which in turn is 8 over 9 d4. Square root both sides. Phi equals the square root of 8 over 9d4. Can anybody tell me what the square root of 9d4 is? 3d squared, and the square root of 8, 2 root 2. And that's what we're asked to prove. That got you 25. Okay? There's 5 left for 30. Okay? Now, determine the limiting speed of the particle that is v goes to v1 as t goes to infinity. What is the limiting speed? Now that's interesting, okay? So, if we go back, the limiting speed. Okay, limiting speed. And it's talking about time, isn't it? It's mentioning time going on to infinity. Okay? So, what we might look at is existing information. We currently know existing information from when we integrated that. We know that phi squared equals, now this is as x goes to infinity. And you want t going to infinity as x goes to infinity, okay? So, we had where is it? This here, okay? I'm just going to rewrite this part here for you. Just give me a second with this. If you imagine, remember in the first question where that was root 3d, we knew what it was, yeah? Imagine that was x. That there is now x instead. Okay? And what we have, instead of that there being what it was, we now have x to the power 4 instead. So it's going to be 2x to the power 4. We're keeping in terms of its distance, okay? And that's still minus 2d to the power 4. Now everything has a 2 in it now, doesn't it? So instead of I'm expressing velocity in terms of distance, the distance variable x, okay? Because I already had it done. So minus 1 over 2x4 plus 1 over 2d4. That's basically what we did already, except I have a new limit instead of using the limit I was given in the first part, okay? I'm going to isolate phi squared. I'm going to say that phi squared equals minus 1 over x4 plus 1 over 2d4. Now, remember what Freeman said earlier? He thought the acceleration should have been negative, but the acceleration is actually positive. So, what's happening over time is you're getting further and further and further away from the object that was there to start. Yes, Finan? When I got rid of the 2, that should be just 1 over d4 as opposed to 1 over... I multiplied both sides by 2 to get rid of the 2. Good spot. Now, what happens is, as the time goes to infinity, so does your distance, because you're travelling further and further away from the point at which you started. So this means that you can use this equation here. What happens when x becomes a really, really big number? And this 1 over a really, really big number to the power 4 is going to become 0. So you're going to get phi squared equals 0 plus 1 over d4. Phi squared equals 1 over d4. Square root both sides. Phi equals 1 over d2. And that's your 30 marks there. Okay.